Hello everyone, we are Team Golem from Shiv Nadar University, India, and we are participating in the University Rover Challenge 2017. We have seen that many teams participate in this competition every year, and our aim has been to build the rover as economically as possible. And to that, we have seen that most of the fabrication is done in-house to reduce costs and make it more economical. The team is comprised of 16 members and has been divided into 4 more sub-teams. The 4 sub-teams are mechanical, electronics, electrical and life sciences. Each team has its own leader and has at least one member communicating with the rest of the teams so as to maintain harmony between all teams during design and fabrication.
For communication, we are using 2.4 GHz. 2.4 GHz Wi-Fi to be exact. We are essentially SSHing into the Raspberry Pi and retrieving back. And the Raspberry Pi has a MJPEG streamer, which is a camera streamer. It is a UDP client server which is broadcasting the data that it is getting onto from the Pi camera. So this is being streamed via the 2.4 GHz Wi-Fi antenna that we've mounted externally. We have tested the range and we have currently been able to get close to 500 to 600 meters. But for longer distances, we intend to use 900 MHz radio frequency. As for the automation part, we are relying primarily on image processing rather than the sensor data such as LiDAR or SLAM algorithms, which would require laser range detectors. Using this, we would be able to guide the robot to its next target destination, at the same time avoiding obstacles in between. As for the electricals, we are planning to use pretty standard industrial motor drivers which uses around 20 amperes of current each. As for the battery, we are planning to use a 20,000 mAh 6S LiPo battery that is 22 volts.
Designing a robot to operate in Martian conditions is a very challenging task for the mechanical team, primarily because of the harsh terrain and environment that the rover will be experiencing. Now, the rover will have to go through trenches, pits and fine Martian dust, and it has to be designed accordingly. This, coupled with the fact that at times we may have very limited knowledge of what's actually happening around the rover, and on the Martian surroundings we may have very low serviceability, which means that our design has to be adapted accordingly. Keeping all these factors in mind, we narrowed down on building a stainless steel tubular frame, which allows us to have very good strength and corrosion resistance characteristics. To ensure maximum stability, we decided to go with a rocker bogie suspension, primarily because it has been successfully used in existing Mars rovers operating on the Martian surface. Also because it is a very simple and elegant solution with minimal moving parts. We went through multiple iterations, prototypes and finalized on a 6-wheel rocker bogie suspension design with a very high ground clearance so as to be able to traverse at least 0.5 meter high obstacles without the fear of getting beached. While designing the electrical box, we decided to take into consideration multiple factors, which include the fine Martian dust and the cooling and routing requirements of the circuit involved. We designed vents and fan positioning to ensure maximum amount of cooling and optimal positioning of the circuitry.
The robotic arm on the rover has been designed keeping in mind all the tasks it has to perform during the competition. It has 5 degrees of freedom to allow maximum movement. The removable end effector can be used as a gripper to pick up objects or as an excavator to dig up the soil. There are 2 linear actuators which have been used for the movement of the major arm, the minor arm as well as the end effector. There are 3 motors present in the robotic arm. One is a stepper motor which is responsible for the rotation of the base plate. Also there are 2 DC motors present which are responsible for the gripping action as well as the rotation of the gripper.
The life sciences team is working on a quantitative and qualitative analysis of Martian soil. We will perform tests that will help us searching the signs of life on Mars. The tests will also be performed keeping in mind the prospect of human settlement, for which the soil will be analyzed for sources of plant mineral nutrients. Some of our simple procedures, such as sample heating and the test for moisture, will be performed within the rover itself, whereas the more complicated procedures, which involve combustion of compounds and test for nitrogen and sulfur containing compounds, will be performed on an on-site laboratory.